Hey guys, welcome back. Welcome back to the second installment, I think it's the second installment, of Learning Algebra with Mr. Bauman from Mr. Bauman's basement. So, second installment, I got many of the same tools and resources. I got the camera, got a whiteboard, got a marker, got the essential for any good math lesson, cold black coffee. Nothing beats a good coffee. And I got the best resource of them all, my eldest daughter, Bean Ann.
Hi.
So she's going to help us out here today. Thanks for joining us, Annie.
You're welcome.
Yeah, this is going to be great. Learning algebra with 2/5 of the Bauman family. How about that? That'd be, what, 40%? Right?
Yeah.
Yeah, 40%. That's some good math right there. So, I hope this finds you doing well on the brink of spring break. It's going to be here before you know it. You smell that?
Yeah.
What's it smell like?
Myself.
I was going to say it smells like spring break because you guys are about 2 days away from spring break.
I smell terrible.
Okay. I think we all do a little bit. But anyways, I hope this finds you guys doing well. I hope this finds your families doing well and making the most of the hand that we've been dealt. And I know I'd much rather be in school with you guys and seeing your smiling faces every day. And I know, Annie, do you agree? You'd rather be in school as well?
Yeah.
But this is the hand that we've been dealt, and we're gonna play with these cards that we were dealt. So I hope this finds you doing well, and I think we're ready to jump into part 2 of section 9.1, graphing quadratics. So as always, if you need to pause the video at any point, if you need to go grab a notebook or any paper, this is part 2 of what we started on, gosh, I don't remember what day it was, but anyways, here we go. Are you ready?
Yeah.
All right, before we begin.
Cheers.
All right. Oh, by the way, I hope you like the new backdrop. I tried to move the chair, move the camera a bit, so you get a little bit different perspective each lesson, each YouTube video. And I hope you found these useful. And so you'll get an assignment, maybe like 3 or 4 problems to do on Google Classroom after you watch this video. So got my tabletop. It's actually our pool table. Mm-hmm. This is the corner pocket of our pool table that's serving as my desk here today. So here we go. We're going to be graphing a quadratic, a little bit more advanced than what we did on the last video. We're going to look at one that's in standard form. So, Anne, if you could write out standard form on the whiteboard of a quadratic, y is equal to, you got it, ax squared plus bx plus c. While she writes that down, I'm going to pull this in a little bit tighter so she doesn't lean so far to get just like standard form, ax squared plus bx plus c. I'll get you the specific one here in just a second. But we're going to look at a quadratic that is more looking like this. As opposed to last YouTube video, we did not have the bx plus c. We just had ax squared. And one of the things that I taught you on the last video is that if the leading coefficient, let me hold that back up. If the leading coefficient, by the way, which is what letter here? You got it, it's A. If A is positive, Annie, what's the parabola doing?
It's up.
It's opening up. We said it's kind of like a bowl, right? If the leading coefficient is negative, Annie, what's the parabola doing?
It's a mountain.
It's a mountain. That's right. Very good. It's a mountain. So let's practice with one today that has not just the ax squared, but today it's going to include a bx and a c. Notice the c doesn't have a variable, which makes c the
constant.
That's right, Annie. It's the constant. It's the constant. That's right. So you want to write down the example that we're going to be doing. You can erase that. Thank you. And I got a magic eraser. If you want to put it all over your nice sweatshirt.
I'll wash it.
All right. All right. We ready?
Yeah.
Here we go. Get your notebook ready. Get your pencil ready. Here we go. We're going to graph the parabola y equals x squared minus 2x plus 1. You know, hold it up in case they didn't get that. If you need to pause the video, y is equal to x squared minus 2x plus 1. And just like last time, we are reading this backwards. So bear with us.
Really?
Yeah, see?
Oh, hi.
Yeah, we're reading this backwards. But there you go. There's our quadratic. So without doing any work, Annie, should this parabola be a bowl or a mountain?
It's going to be a bowl.
It's going to be a bowl. Why is it going to be a bowl?
Because x is positive.
Which one? The one in front of x squared, or the number in front of x, or
the one in front of x squared.
Very good, which we call the blank coefficient.
Leading.
That's right. It's the leading coefficient. That's right. So even though you can't see it, there's really technically a 1 right here. So if it helps, you can put a 1 in there. And underneath it, it's going to be hard to write upside down, but you could label that as going to be A. The number in front of x we called
B.
lowercase b. There you go, good. And the number that doesn't have a variable, that's lowercase c. If that helps, you can label those A, B, and C.
Okay.
Very good. All right, perfect. Now, in order to graph this bowl-shaped parabola, this right-side-up parabola, the first thing you need to calculate, if you need to look back in your notes from a couple days ago, first thing you need to calculate is the x-coordinate of
the vertex.
That's right. Very good. The x-coordinate of the vertex. Did you take this last year?
Yeah.
And this year as well?
Yeah.
That's right. You're in Algebra 1 honors, right?
Yeah.
For those of you that were curious. So many of you are going to be in the same class this coming fall. So is it safe to say you're going to see that these guys are going to see quadratics again? In fact, you just finished quadratics how long ago?
A month ago.
About a month ago?
Yeah.
Yeah. Pretty much studied the same thing
Yeah.
that we're studying here today. So it's a great introduction to it here in this YouTube video, and know that you're going to be seeing lots of quadratics. All right. So let's find the x-coordinate of the vertex. So the formula that we looked at the other day, x equals the opposite of b. Some people say negative b. I don't like to use the word negative because the top is not always going to be negative. So I always say the opposite of b, that goes on the top, divided by 2a. Annie's going to hold it up here. This is what the hokey pokey is talking about. This is what it's all about, right? Without this, it's really tough to graph this parabola. This is kind of like the springboard. This is the first step to take. If you're taking the ape test, definitely want to write the word ape next to this formula. All right, so let's go ahead and calculate that. If we do, that's right. How many times do you think I said ape last year in class?
I really wish someone counted, but I don't know. A lot.
In the hundreds?
Yeah, definitely.
Yeah.
Yeah.
All right, let's calculate this. X equals the opposite of b. The opposite of b is actually what number? Positive 2. That's right. Very good, Bean Ann. It's positive 2 over 2 times 1. So she's kind of drilling down here. Hopefully you're doing the same thing in your notebook. And we get x is equal to 1. That is a very important number for our parabola. And every quadratic, this is not going to be the value of x.
Nope.
Sometimes it's 1, sometimes it's 0, sometimes it's a negative. For this particular quadratic, our x value is 1. Now, this really serves two main purposes. Number one, I got to take a drink of coffee. Number one, this number, x is equal to 1, represents, we already said it once, this is the x-coordinate of what, Annie?
Vertex.
The vertex. So if you could label that for them, just so they know that this one kind of purpose of this number, it's the x-coordinate of the vertex. Literally, when we draw the ordered pair, we write the ordered pair, the x value in that ordered pair is 1 for this quadratic. But secondly, this number 1 also represents,
the axis of symmetry.
that's right, very good, it's the axis of symmetry. That's that imaginary line, for this year it's going to be this imaginary vertical line that runs right through the heart of your parabola. It's going to split that bowl shape, it's going to split it into a left side and a right side. So if you folded them together, they'd fold right on top of each other. That's what the axis of symmetry is, that imaginary, if you could like just draw like a generic parabola and show them what the axis of symmetry kind of looks like.
Kind of looks like that.
There you go. So there's what our parabola is going to look like. This dashed vertical line, you always dash the axis of symmetry because it's technically not part of the parabola, but it is that imaginary line. It's kind of like the crease in your paper that you could fold the parabola onto itself. Perfect. So our number 1 serves both of those purposes. Okay? All right. We ready to make a table?
Yeah.
All right, let's do it. So I give you a chance. You don't have to erase anything. You got your notebook. As Annie writes all over my pants here.
Sorry.
That's all right.
Here.
There you go.
Okay.
All right. We ready to make the table? All right, so we got an X column, just like we did with the lines back in the fall. Same thing. We got an X column. The real wide middle column, that's where all of the calculations are going to go. And then we have a Y column, or an output, which we call the range. X is the domain. That real large middle column, that's where the function goes. This time it's a quadratic function. And then the last column, the Y column, is the outputs or the range values. Annie's finishing her table up here. What we're really, that's fine. What we're really producing here is going to be some ordered pairs. And with those ordered pairs, we can start to graph that bowl shape. She's even added her own column at the end, which is all of the ordered pairs that we are trying to get. If you want to go and hold yours up. Perfect. Thank you, Annie. Okay, so there's what your table should look like. Notice, Annie, how many kind of empty rows do you have?
5.
5. 5 is a good number. The very first one is actually going to be what part of your vertex? I just gave you.
Yeah.
What part of the parabola?
Vertex.
It's the vertex, that's right. The first one is going to be your vertex. So, your very first x in your table is the number that you just got like 2 minutes ago. For us, and for you, it's the number
1.
Number 1. Very good. So if you're going to include, oh, you already did that.
Yeah.
Look at that. So at this point, you can go ahead and fill it in your ordered pairs, 1 comma blank.
Something.
Okay? We're going to let our function do all of the work to get that output, or that y. The function was y equals x squared minus 2x plus 1. So right now I'd like for you, and as Annie works hers out, I'd like for you to find the corresponding range value when the domain is 1. So she plugged 1 into the function. So why don't you guys right now, if you need to pause the video, go ahead and pause the video. Let's go ahead and get that output.
Yeah.
Okay. When we're back. So we got an output of 0 because, I'm trying to read backwards here, 1 squared minus 2 times 1, that's 1 minus 2, that's negative 1. Then add the constant, negative 1 plus 1, that's 0. So far we know 1 point on our parabola, 1 comma 0. So, Annie, we have 4 rows left. What would be some good choices for x's? What would be some good choices for these domain values?
How about 2 and 3, and 0 and negative 1?
Okay, so
Okay.
why'd you choose those 4?
Because they are equidistant to each other.
Good. And
To 1.
very good.
Yeah,
Which is
the vertex.
The vertex. Perfect. It's all of 4 numbers that she chose. All 4 numbers have a partner or a pair on the other side of the parabola that is equidistant to the vertex. So if you could hold up the board so they could see what you chose. So she chose 2 and 3. That's the nearest two integers to the right of 1. 0 and -1 are the nearest two integers to the left of 1. Could you have chosen, Annie, for the second one? Could you have chosen 2.1?
No. Yeah.
You could have, but what would it have done to all of your calculations?
It would have made them all decimals, and that's not good.
Yeah, it would have made them all decimals. Not that it's wrong. It just is a tough calculation, right? Could you have, instead of 3, could you put 3,000?
Sure.
Yeah, but what would it do to your calculations?
It wouldn't look nice.
It wouldn't look nice. And it would take you a long time, right?
Yeah.
And you get some really funky number for your output. So be smart, be wise about what x's you choose so that your calculations are as straightforward and as accurate as you can get them. There's something else I wanted to say. Oh, by the way, the partners here, 2 is 1 unit away from 1, and so is 0. 0 is 1 unit away from 1. It's a glare. There we go. So because these two numbers and these two numbers are equidistant to the vertex, Annie, what should happen to these two?
Should have the same outputs.
Perfect. They should have the same or equal output. So go ahead and pause the video. We're going to do our calculations. You do your calculations. Unpause the video here in about, 1 minute. And we'll come back together and see what kind of outputs we get. All right, let's start hammering away. We're actually not going to pause the video. You pause yours. Good. It's the easy one. Yep.
I know what it is. Remember what it was. Oh yeah. Here we go.
Good. Make sure you're doing order of operations.
Yeah.
PEMDAS. You got it. Great. All right, and we're back. She's filling in her ordered pairs right now. But we got, and hopefully you got the same thing, we got
That.
this table. 2, 1, 3, 4, 0, 1, -1, 4. I'm reading backwards. I hope I'm reading those correctly. So, now that we have our ordered pairs, I think we're ready now to transition from the table to an actual graph. If you have graph paper at home, by all means use it. If you don't, you can, and you have a printer, you can actually print off your own. We don't have graph paper on this whiteboard, so we're going to try our best to make do. That's right. So we're going to try to make ours as neat as we can. If you have a straight edge at home, it might be helpful to draw your coordinate plane with a straight edge. Close enough.
Not even straight.
That's PDC. So, also, when you get your assignment on the Google Doc, I think, and thanks to Charlie Baker, he sent his with the graph included or inserted into the document. That's just one less thing for me to have to open times 22 students. So if you're able to insert an image, a picture, please do so. So once you graph this on your homework, if you could take a picture of it with your phone or your parents' or grandparents' phone, if you could take a picture of it and then insert that photo of your graph right into the Google Doc. That way all of your answers are on the same document and I'm not bouncing back and forth between the Google Doc and emails from you. So if you did on the last one, great. If we could all try to insert a picture of your graph onto the Google Doc, that would be fantastic. All right, Annie's wrapping up her parabola here. She's plotted all 5 points. Since it's a bowl, it's going to have a minimum. It's going to have a lowest point, and for us, that's our vertex. So her lowest point is 1, 0. She's darkening in her points so it's easy for you to see. And you should have a graph, that looks great, a graph that looks like this. One of the last things you should do, and out of habit, she's already done it, put arrows at the end of both sides. By the way, if we had only chosen points to the right of one, we would have got like that half parabola, like the kid up on the AMBO doing the petitions. We want both arms of the parabola, so that's why you have to do 2 to the right, 2 to the left. The vertex being the lowest point for this one. Oh, and she actually already included that. Look at you. That's awesome. She actually also included the axis of symmetry. So if you could dash in the axis of symmetry today on your Google Doc, that would be great. The last thing I'd want you to try to get in the habit of doing is naming the quadratic. She doesn't know the name of it because we don't have it written down on the board, but it is y equals x squared minus 2x plus 1. And the only reason we do that is when you get to high school, you're going to start doing more than one parabola on the same coordinate plane. So if you don't start to get in the habit of naming each one, and next year you're going to have like 3 or 4 on the same graph, it becomes a little confusing on which one is which. So just try to get in the habit of naming it. So at this point, if you've done yours on paper, which I'm sure you have, you could take your paper and crease it right along this axis of symmetry, fold it on top of each other. You could almost hold it up to some light, and one arm should be matched up right onto the other arm. That's awesome. Yeah. Isn't algebra amazing?
Yeah.
I mean, seriously, can you think of anything more intriguing than algebra?
Probably.
Give me one thing that's more intriguing than algebra.
Food.
Good answer. Good answer. This is like
food.
Huh?
I like food.
Food. Food is good. Food is really good.
It's really good.
Yeah. Favorite food?
Cake.
Cake. Hey, on your Google Doc, if you could at the bottom, question number 5, because I think you only have 4 questions today. Question number 5, give me your favorite food.
Okay.
And try to be as specific as you can. Cake, a good answer.
Cupcakes.
Cupcakes, what flavor?
Chocolate.
Chocolate? Like the cream cheese icing, or more like the fluffy, like marshmallowy?
Fluffy marshmallow.
Okay. Question number 5. See who watched this video, because I'm not going to put it on the Google Doc. If you watch the video, question number 5, favorite food, be as specific as you can. You got anything else, Annie?
No.
This has been great.
Yeah.
This has been really great. Thanks for your help.
Welcome.
Yeah, this is amazing. You're awesome.
Cool.
You guys are awesome too. And I miss you guys a lot. I wish we were at school doing our algebra in room 202. But we're going to continue to do the best job we can with the circumstances that we've been dealt with. I really appreciate your guys' effort and your time and your work. Seriously, I really do appreciate it. Teachers are working hard, and I know students are working hard as well. So you keep doing the best job you can, and know that your efforts are noticed and appreciated. I'm going to keep moving forward with Chapter 9. My goal for you guys is to finish Chapter 9 here in April. So most of it, all of it, is going to be through YouTube. And we're going to get through Chapter 9. Hopefully May 1st, we're back in school. We'll get through the first couple sections of Chapter 10. And that's exactly the point that I get to every year. So our goal has not changed. The scenery has definitely changed. We're not in room 202, but I'm going to do everything I can to make sure that you are as prepared as you can be, feeling as comfortable and as confident as you can walking into that first day of algebra. So, on behalf of Annie and I, it's been a pleasure. Whoosh. See if you can make that sound effect. But seriously, I won't see you again until after spring break. So have a wonderful, relaxing, enjoyable, safe, and healthy spring break. Enjoy your time kind of unwinding a little bit. This is like Simon Says. Simon says, open your hands. Simon says, close your hands. Simon says, point a couple times. Have a wonderful time sleeping in. Hopefully staying up late, watching some good movies, and just enjoying your family. Your family loves you a lot. Your teachers love you a lot. Your school loves you a lot. You keep doing the best job you can. As I say in every email that I've sent you in the last week, be kind to one another. We are all trying our best. I know the situation is not ideal, but be kind to one another. Be patient with one another, because we all need a healthy dose of patience every once in a while. And most importantly, more important than anything we've talked about, make sure you pray. Pray for your family, pray for your friends, pray for our school, pray for our country, pray for our world, pray for me. I need it. Know that you guys are in my prayers every single day. I'm praying for your health and well-being and safety over these next couple weeks, over the next month or so. And know that you're in my prayers daily. And pray for peace, because I think we all need more peace in our life. And I think that's prayer is the perfect form of peace. So, Bean Ann, anything else?
No.
No? Thanks for being my assistant today.
Welcome.
That was awesome. You're awesome. Guys, have a great spring break. I'll catch you at the next YouTube video after spring break. So, until then, be safe, be well. Peace out. See you guys.
Bye.